Hey, g'day, it's Prezzo here. Now, this sorry piece of junk that you see before you was given to me. In fact, I spotted it underneath my mate's workbench. And it sat there looking dusty and horrible, and I felt like it was mocking me. It sort of seemed like it was saying, I'm a piece of junk and there's nothing you can do with me. You might as well throw me away. And I thought, it's a wood cutting bandsaw, but I desperately need a metal cutting bandsaw. So in terms of metal cutting kit, I've already got one of these, and all of these.
What about me?
Yeah, well look, no one likes you, you've got no friends. So just get back on the wall where you belong, Nigel. The problem I have is that sometimes all I want to be able to do is to freehand cut a piece of aluminium, like thin material, maybe 3, 4, 5 millimeters, maybe steel, and I want to be able to quickly slice off an edge or cut a curve or cut into a corner or an already drilled hole, and the tools that I've got already really don't do that well. If I was to have a metal cutting blade in this, and if I could get it running at the correct blade speed, that would be a huge advantage. It's small enough and light enough that I can just put it up in here on the bench. I can store it away when I'm not using it because I don't have a lot of space. And I think I can make it work. Okay, so what's involved in turning this into some sort of a useful workshop tool? Well, the first thing is that these wheels are very, very thin and light. There's some sort of a zinc-based die casting. I'm going to need something which is the same diameter, slightly thicker on the tie area, and I want a lot more material around the bore. These metal cutting blades need a bit more tension than the thinner blade that would have been on this when it was being sold. So that's it. First thing, I'm going to replace these wheels. They'll be just an aluminium casting, sand casting, machined and fitted to start with to the same bearings. If that proves to be too light, then we can upgrade the bearings later. Right, next thing is this motor. Now, this is a 250 watt motor, about 1300 RPM, and previously it was direct drive onto the bottom wheel of the saw. So the blade speed must have been huge, but it's totally unsuitable for cutting metal. I want to get the blade speed down to about 70 to 80 meters a minute. And to do that, we're going to need to fit some sort of a reduction speed drive onto the motor and somehow get that operating mechanically inside the bottom of the saw. A lot of the adjustments on this are just cheap polymer. Don't know how long they're going to last, so we'll probably upgrade those. All of the electrical switchgear is good. This has got a relay switch. Motor and everything still runs, so that's fine. Interestingly, it came with a laser line guide which shines down here on the table. Now I can't even imagine why they would have included that little luxury on a saw this cheap, but it's there, and we can probably get that going. It was battery operated. I'm going to try and run this from some sort of a switching power supply so it's sort of on all of the time. So that's the project. We're going to try and turn this piece of junk into something that might be useful around the workshop. So let's get going. This is a 250 watt 1400 RPM induction motor, and I need to be able to match this to a metal cutting bandsaw blade. So the blade that I'm using is a 13mm wide blade, 1400mm long, and I can't tell you the teeth per inch, but it was sold as a bimetal blade for cutting steel and aluminium. And at 1400 RPM I'm getting a blade speed of 1960 meters per minute, which is outrageous. I mean, it's even fast for wood, but for metal I need to get that down to somewhere around about the 80 to 90 meters per minute. Now I was able to purchase one of these. Now this is a worm drive gearbox, and it's sold as a NEMA 34 reduction gearbox. The mounting holes for the input to the motor are close to, but not exactly the same as the mounting holes that I have here. So I need some sort of adapter plate to be able to do this. Now also the input diameter of the bore is not quite the same as what I had on the motor shaft. I took the motor shaft out of its casing and I turned that on the lathe to a diameter of around about 14 millimeters. Now I say around about because This hole in the input side of the gearbox is tapered. Don't know why. I'm sure there's some reason for it, but it was very hard to actually get a diameter on the bore. As it turned out, I was able to get that to fit in that far, and then it sort of bottoms out on the taper, and I measured the gap here, and I've made an adapter plate, actually cast it from this pattern here, and that's going to allow me to sort of take up the space between the motor and the gearbox. I can also work out my hole centers and use studs or screws or something to be able to rigidly mount the motor onto the gearbox. Now that's not ideal, flexible coupling would be better, but I think I can get away with it. This is the original wheel from the bandsaw, and I've been able to turn that and fit it onto that shaft there, but this wheel is really too light. It looks like a zinc-based alloy die casting. It's very, very flimsy, so I've made a pattern here for a bigger, beefier wheel, and I'll cast this in aluminium as well. So that's the plan, and just by pure good luck, these hole centers here match up exactly with the hole centers in the back of the bandsaw frame, so I can just simply use screws to mount the gearbox directly to the back of the bandsaw frame, and that makes this whole unit really compact. And even though this is only 250 watts, by the time we get our reduction, which I'm looking at being 30 to 1, that's going to give me a blade speed now of 65 meters per minute, which is a little bit fast for steel, maybe about right for steel, and probably too slow for aluminium, but it's a good compromise. So that's where we're heading with this. I'm not going to show you all of the machining processes because there's a lot in it, and we're just going to catch up with the process as we go along. This is the raw casting for the motor mount. Okay, so there's the adapter plate machined on that face there. That's important, that's a good mounting face. This diameter here is a really close fit on the bore inside the gearbox. The hole on the inside here is just clearance, so that's not really all that critical that we get that right. So the gearbox now just bolts up against that face there, and all I need to do now is get the thickness of the casting correct, and also cut the mounting holes for the 4 fixing bolts here, and they're soldered holes, so they're don't have to be terribly precise. The ones on the motor side we do have to get correct. There it is, sort of partly assembled. When the replacement wheel is made for the bandsaw, I can take this one off and it'll have a keyway cut in it as well. I've got to get some mounting holes drilled and tapped through the adapter plate here. It's looking good. This is the pattern I'll be using for the bottom drive wheel on the bandsaw. This is just cut from a single piece of MDF. The large holes were just bored out on the drilling machine, and I did all the profiling on the wood lathe. And I used exactly the same pattern for the top wheel. The only difference is that I'll be adding this extra boss on the back for the bottom drive wheel. And this is just to give it the offset from the gearbox. So we'll go ahead and get the pattern into the mold, and we'll get it rammed up, and I'll show you the gating that I'm using on this because it's a bit unusual. So this is the gating system I'm using, and what I'm trying to do is get the metal to run down the sprue, which is going to be right here, and then fill the thickest part of the wheel, and I can get basically all the spokes except this one, so we're going to have to hope that the metal does flow right round to the back. The last time I did this, I think I only used 3 ingates, and the mold didn't quite fill in this spot here. Now this time I'm going to heat my metal up to a higher temperature. I'm hoping these more gates and deeper gates are going to help. So I'll get this pattern out, and then we'll put it together and see what we get. Okay, that's broken away a little bit there, but that won't matter, it's going to be machined. So I'll just get the gates cleaned out here. So here's my pouring basin. I've got a large riser in the center here, but not as much depth in there as I would like. But yeah, I might get some shrinkage. We'll see how we go. Success or not. All right, I'm pretty happy with that. There's a very slight depression on this side of the casting here where the metal shrunk. I'm not convinced that's going to be a problem because I've got to bore through there anyway. And on this side, even though my riser was very short, it's done its job. It's kept the metal fed as it shrunk, and this section here, which mounts onto the gearbox shaft, is good. I can't see any areas on these spokes where the metal has refused to flow through. They all look good. There's a little tiny like a hole there, which I think is just like a sand grain that got dislodged. But everything else about that casting is as good as I want it to be. I know it's not the most perfect surface finish, but I'm not after that. I just wanted a sound casting that will machine up to my finished sizes, and you know, I think that's good. That fits the bill. Happy days. Time for a beer. Alright, as you can see, I've been doing some machining, and what I've done so far is just face off that boss, and I've machined the diameter of the wheel down to the correct measurement. Now before I turn this around, do anything, or bore out the center of the wheel, I need to get the camber on the edge of the wheel. Now if you're familiar with bandsaws, you'll know that the wheel itself needs to have very slight curve in the rim. If you're not familiar with it, that's the means by which we can get the bandsaw blade to actually ride on the wheel without any need for a rim or an edge to constrain that blade. So the way I'm going to do it is I've already marked this out with some blue dye. And I'm going to mark 5mm and 10mm across the rim of the wheel. The wheel is going to finish at 15, so that's going to give me 1/3 or 5mm on each edge, and that is going to be machined to a 1.5 degree taper, and then I'll blend the rest of that with a file. So I'm just going to mark this with a pair of Jenny calipers just to give me a position for the edge of that taper, and doesn't need to be really super accurate. So that'll be the edge of my taper on the front edge, and that'll be the back edge. I haven't machined the back yet, so I'm just going to measure 10 from the front face. Right, so there's my scribe marks, so I'll get that taper cut on there, and then we'll just blend that with the file. I'm just using my tangential tool holder for this job. My lathe is really underpowered, and I bought a lot of insert tooling, and it just doesn't work. I can't get it to the feeds and speeds that I need because my lathe has an undersized motor. Originally it had 7 horsepower, 3-phase motor. I had to convert that to single phase, and I was too poor to buy a big motor, and I regretted it ever since. But this high-speed steel tooling works really well in this lathe, and it's cheap, it's easy to grind, and these are sold by a company called Eccentric Engineering, and they don't sponsor me. I'm not getting paid to say this, but I love these tool holders. They're worth their weight in gold as far as I'm concerned. I've got 4 of them, and I'll put a link in the description below if you're interested in buying these, because they really are good value for money. So I'll get this set up and I'll cut that taper. Alright, so this is the first one, and I'll swing it around the other angle, 1.5 degrees the other way, and we'll cut the back one. Alright, to blend that I'm just going to use, this is a long angle lathe file. It's specifically designed for filing in the lathe, and once again it's a fine addition to any shop. So I'm just going to get this into a blended sort of curve. Alright, that's not bad. It's sort of picking up and scoring a bit, and I think the reason for that is that it tends to get a little bit of sand included in the casting, which is probably not the best thing for the file, but that's done. I'm not worried about the surface finish. That's going to give it a bit of grip, and that's given me just that very slight amount of curvature on the top of the wheel. I've just drilled that centre boss there at 16mm diameter, and I'll finish it at 18 with a reamer. So I'm just going to bore this out now to close to that size, and then I'll cut a keyway in this before we turn it around and do the back. I need to be able to make an extension for the gearbox, so this wheel will line up with the top wheel. Unfortunately, the shaft on the gearbox which drives this wheel is not long enough, so we're going to have to work some way of doing that later. But I want to make sure that this bore is exactly concentric with the rim of the wheel, so that's why I'm doing it now. More speed. Well, I've got an 18mm reamer, but it's a hand reamer and it won't fit in my tailstock chuck, so I've got it supported here on a centre, and I'm just going to run this really slow and just stop it from turning with my spanner. Let's just see how this works. Well, that's good. So I'm just going to do a bit of chamfering here before we turn it around. Oh, and I've got to cut the keyway. Better not forget that. Okay, that's pretty good. Just got to get the keyway in here and now we can turn this around. This is my setup for cutting the keyway through the wheel. This is just a home-built slotting attachment that bolts down to the top of my compound. I've got a series of boring bars that I can fit into this ram, and I've got different size tool bits as well. So this one's 6mm wide. That's the key that we're going to be using to attach the wheel to the axle. So I've got my DRO set up here, and I'll bring the tool 3mm toward me, which will give me half the thickness of the key, which is 6mm. So I've just put some WD-40 in there just to act as a cutting fluid, and it's just a lot of hard work. And just in case you're wondering, I've got the spindle locked with a indexing attachment at the other end of the headstock, and I've got the motor out of gear so nothing can go wrong. I can't accidentally turn that wheel and lose the indexing of that slot. Alright, that should be it. That's about 3.1mm deep. There's our freshly machined keyway. There's the key. That's all good. A bit of a defect there. Does it matter? No, not really. Alright, well that's the back of the wheel cleaned up. I'll need to drill a hole and cut a thread in there later on for a grub screw, but I think that's all done. Okay, I thought I'd give you an update on the drive system for this bandsaw as I wind up this episode. So what I've got so far is the motor attached to the spacer, and that in turn bolts through to the flange on the gearbox itself. It's just all temporary at this stage. So that's driving through the worm and to the wheel inside the gearbox. Now the shaft that came with this gearbox unfortunately wasn't long enough to allow me to mount the wheel directly to that. So what I had to do is to make an extension. So this is just made from mild steel. It's got a 18mm stub on here which engages on the wheel with a keyway cut in it, and this bore fits over the shaft on the gearbox. Now the shaft has its own keyway, and ideally what I should have done in here was to cut a keyway, but I got lazy and I just took the cheats way out and I made a grub screw. This is an M8 grub screw. It's got a 6mm shoulder on it, and when that's inserted through into the bore, it engages in that keyway. Now you're probably sitting there and saying, well, that's not very strong. You can easily shear that screw off, which is, yeah, it's true. I doubt it. So I can just simply tighten up that grub screw and I've got a positive drive to the wheel. Somehow, where is it? There it is. So I can lock that down. You know, if I shear that off, there's something wrong. So now I can mount the wheel directly to the end of that extension. And there we go. So what I can do here is to fit a washer over that. I'll cut the key back and put a socket head screw through to hold all that together. Now I know I said I was going to put a grub screw on the back of the boss, but this is easier. Now I also made this part. This is a standoff, if you like. That's a spacer. So this allows me to get the motor clear of the back of the bandsaw itself, and that all mounts on there with M6 screws. So I'm going to show you what it looks like in the bandsaw itself, just so you believe me and just so you know that it works. Alright, well here it is, sort of assembled. I'll turn this around and you can see the motor there and the gearbox, and I reckon that's a really neat solution. It's sort of compact, it doesn't hang over the footprint of the bandsaw, so I'm stoked with that. It's great. Now I'm going to run this and you're going to notice something straight away. Did you spot it? Yes, that's right, it's running too slow. And the reason for that is the gearbox that I've got mounted on there at the moment is a 60-to-1 gearbox. And what I said I was going to include was a 30-to-1. Now, it turns out that I bought that gearbox for another project. It's a sand muller. And when this bandsaw was given to me, I thought, I wonder if that'll work. So I sort of tried it. And I figured that if it was successful, I'd go ahead and buy the 30-to-1 gearbox to replace it, because they're identical in terms of the mounting and the form factor. So when I get that on there, we'll get the blade speed that we want for cutting metal, steel and aluminium. Now I've actually had the blade on this and I've cut some metal. It's slow, but it does work. The blade tracks okay. I've got some modifications to do on the bottom of the saw here just to strengthen this back plate. With the tension on the blade, it tends to want to skew that wheel, and the blade wants to ride about halfway off the wheel. But if I make that reinforcement plate and shim it and so on, I can get the blade tracking correctly on the bottom wheel. Now I've left all of the original blade tensioning and tracking adjustment on the top of the saw as it was manufactured. That's all seems to be working. Okay, in the next episode you're going to see me doing the blade guides and fitting those to the saw, and you're also going to see what I did about the motor. Now there's a bit of a sad story about that, but I'll share that in the next video. So for now, I'm going to wind up here and invite you to come along next time and see if we can get this into a useful workshop edition, because pretty much as I got it, it was a heap of junk. But join me on that one and we'll check it out. And thanks for watching. And it does work, all right?